Okay, we're going to look at some probability distributions. And so the probability distribution I'm going to look at is we're going to do 3 trials. So n equals 3 with a probability of success on each trial of being 3/4, which is the same as 0.75. And what we're doing here is we're going to do a binomial distribution, and we're going to look at each probability of the binomial distribution. And so we could have the probability of 0, the probability of 1, the probability of 2, and the probability of 3. And there's a couple different ways we can look at this, but what I want to try to focus on is, let's say, what is the probability of having 2 or more, or we'll say at least 2. So what is the probability of at least 2? Or we could say that x is greater than or equal to 2. So it's the probability of x greater than or equal to 2. Now, there's a function on the calculator called the cumulative. So it's binom CDF for cumulative. What it does is it adds everything up to including the number you have. And what's really nice for that is when you have things that, if our probabilities are like 6 or 7 or 8, and we don't want to add up all the probabilities. So what we're actually saying here with a greater than or equal to 2 is we're saying the probability of 2 or the probability of 3. 2 or 3. And if you remember correctly, our ORs were additions. And so if our probability space is very, very large, and the way the calculator uses a cumulative distribution function, for greater than or equal to's, we want 1 minus the probability of everything x being less than 2. So what does that mean? If I come up here and I go, well, if I want the probability of 2 or more, I want these things. And the probability of less than 2, I want these things. But what will happen is you'll find that our calculator adds upwards. And so it's going to be easier for the calculator to get these. So the first thing I'm going to do is I'm going to show you using the cumulative distribution function, and I'm going to show you in bits and pieces. So for right now, what I'm going to do is I'm going to do on the calculator 1 minus the binom CDF. And what do we have? We have 3 trials with a probability of 0.75. And the last thing in the cumulative is going to be a 1. And so that's how we're going to enter it. So let's see how that looks on the calculator here, okay? So let me pull up the calculator, see if that works. Rockin'. And so I want the probability of at least 2. And so the complement space is everything less than 2. So doing a complement, I'm going to do 1 minus, and I'm going to go to math and probability. Oops, not math and probability. I did this the last time too. Always, because I guess I'm talking about probabilities. I think probabilities, but I want to go to second and distributions. Bear with my craziness some days. And I want the binomial CDF, cumulative. So I'll hit enter. And we had 3 trials with a 0.75 probability of success. And we want the 1 is the number that's less than 2. Because remember, the complementary space is less than 2. And so all said and done, it pastes this in. If you don't get the menu option, some of the TI-84s without the plus, when you choose the binom CDF, it'll just plop you down to the parentheses. So it's the number of trials, comma the probability of success per each trial, comma your x value. And it gives me 0.84375. So I'll write that down on the blackboard here. Let's get back to it. So this will be 0.84375, did I say? 375. 375. Well, let's do it by hand. Let's put in these two probabilities in the calculator and add them up. So come back over here to our calculator, and I'll go to second and vars, and what I want is the binomial probability. 3 trials is a 0.75, and I wanted 2, and I want to add to 2 for 3. So second distribution up to binomial PDF, no, not Poisson, binomial. We have 3 trials and we wanted the x value for 3. And notice we get the same values. So let's go back here. So this works as we said. What you will find is that a lot of binomial distributions will have 12 or higher, right? We'll have large numbers. And if we'll say, what are your odds of being x greater than 5? Well, you would have to add 6 or 5, the probability of 5, 6, 7, 8, 9, 10, 11, 12. And that gets a little bit hard. But if you use the cumulative distribution function, then all you have to do for the cumulative would be 1 minus the binom cumulative, whatever your percentage is, up to 4, the number before the one you look at. So using our complementary space can help us do some of these distributions a little bit easier. Unfortunately, this only works on the statistical calculators. On the TI-30s, you either have to use the table or you have to add them up by hand. Always always go with your complementary space. It will be the quicker addition or subtraction.